Alright guys, for our final section of Chapter 11, we jump into circles on a coordinate plane. So we've spent the first part of this unit talking about angles and chords and tangents, and now we get into, graphing a circle and the equation of what a circle would look like. Okay, most of what you guys have been working with up until this point in geometry are lines on a coordinate plane, or even maybe some parabolas. Okay, and now we get a standard stock equation for what a circle looks like, and then based on the properties of that circle, we would be able to then graph it. There are a couple formulas we should recall that might be important depending on what is given and asked of you in this section. The distance formula, square root, this is when you're given 2 points, okay, x2 minus x1, y2 minus y1. If you're given 2 points and want to find the distance, or this could be helpful in this section to find the length of a diameter or radius. Okay, remember the distance between 2 points would be the same as the length of that segment. Okay, and might be important here to terms that apply to a circle. Okay, the midpoint formula, that's just the average of the x's and the y's. Okay, this might be helpful. To find the center of a circle, let's say I give you the 2 endpoints of a diameter. Well, we know a diameter goes through the center of the circle, and the center would then be the midpoint of that segment, okay, the point directly in between the 2 endpoints of the diameter, okay. And then we have the standard equation of a circle, okay. There are 2 things that you will need to know about a circle to be able to write the equation of it. 1 is the center, and 2 is the radius. If you can find the coordinates of the center, and you can find the length of the radius, you will always be able to write the equation of a circle. Okay, and vice versa, if we have the equation of a circle, we should be able to identify the center and the radius, and then be able to graph. Okay. The center in this standard equation of a circle is the h and the k. The h represents the x coordinate of the center. The k represents the y coordinate of the center. Notice that they're attached to the x's and the y's, added or subtracted. There's minus signs in the formula, and obviously the r is the length of the radius. Okay? And you'll see how very simple this is depending on the information. If I tell you, like in example 1, what the center, where the center is located, and the length of the radius, this is a very easy problem to do. It's very easy to write this in standard form. A couple things to note. One, most importantly, is that there are minus signs in the standard equation. The general form of this have minus signs, which means in here you'll basically have the opposite of the sign of the x and the y coordinate of the center. Okay, these are positive, but when we put them in for h and k, you'll see that the minuses still stay there. Okay, so let's do it. Write the standard equation of a circle with center 3, 5, radius 7. Well, if we want to, we can label these. This will be my h, this will be my k, this will be my r. And all we have to do now is plug them into the right places. I'll even leave some spots to do that in a different color so you see how this goes. We plug the h in here, we plug the k in here, we plug the r in here. And then all we need to do is clean this up if needed. And we will certainly need to square the 7. We can do that. Okay. If there was a negative, like a minus -3, obviously that would change to a plus. Same thing would happen here, but not in this case. Let's square the 7 and call it a day on this problem. This would be our answer. This is the standard equation of a circle with center 3, 5, and radius 7. So let's do one more. Standard equation of a circle, center 5, -2, radius 6. X minus, there's our h, our k, and our r, squared, plus y minus, now we have a -2 here. Anytime we're inserting a negative number into a formula, I always like putting parentheses around it. This way we can deal with this minus and negative. Nothing to clean up here, but we definitely need to turn this minus and negative into a +2. and then we square the 6. I think you guys will start getting good enough where you kind of skip this step. Okay, you know this is a negative number, and we have a minus in the general form of this equation, which means we'll have kind of the opposite of that sign, which means if one of the coordinates of the center is negative, you're going to have a plus inside that parentheses. Okay. Example 3, we don't really need to tackle that, just squaring the square root of 2. Remember, if we square a square root, it just cancels. Okay. Let's move along to example 4. 4 and 5 are the same problem with different numbers, and we're going to talk about 2 different ways to do this. Okay. Passing through the point 2, 2, that means this point is on the circle. Okay. All right, first way. Use the point on the circle as the x and the y in our equation. Okay, so I'm going to rewrite the standard equation. X minus h squared plus y minus k squared equals r squared. We need the center, hk, and we need the radius. Which one don't we have right now? We don't have the radius. How can we find it? Well, one of the options is to plug in these 4 numbers into our equation, and the only variable left will be r. Okay? Any point that lies on the graph of a line, a circle, a parabola, this can be considered x and y in terms of the x and the y in our equation. This is the center, which means this is our h and our k, and when we plug these all in, the only thing that's going to be left is r. So we get x, which was 2, minus h, which is 1, squared, plus y is 2, k is negative 3, squared equals r squared. Okay, we plug in the h, the k, the x, and the y, and now we just do math. 2 minus 1 is 1, 1 squared is 1. 2 minus negative 3 is really 2 plus 3, which is 5. 5 squared is 25. That's going to equal r squared. 26 equals r squared. And we take the square root. R equals the square root of 26. Now, we really didn't need to do that because on the right side of this equal sign, we're really looking for r squared. It's nice to know what the length of the radius is, but for the purpose of our equation, we could have stopped here. We know r squared is 26. So I'm going to put a 26 in here. That's for my r squared. We're writing the standard equation, so we're not done. Okay. Here's where students get into trouble for some reason. They want to use the 2's again when writing our standard equation. Anytime you're writing the standard equation, you should always have an x and a y. Go back to the ones we wrote up top. We have the x, we have the y. We have the x, we have the y. All we're doing is plugging in the numbers for the center and the radius, the hk and radius, hk and radius. So let's come back down here. Now I know we used these to find our radius, but when we're writing the standard form, these don't matter anymore. So x minus 1 squared, there's our h, plus y plus 3 squared, there's our k. We flip the sign, minus and negative 3 is a plus sign, and we're done. That's one of 2 ways we can do a problem like this. We can use the point on the circle as our x and our y, plug in the 4 values, find r or r squared. The second way we can do this is by using the distance formula to find the radius. Okay. They tell us that the center is 2, 3, and this point negative 1, 1 is on the circle. If I draw a segment from the center of any circle to a point on the circle, that's a radius. Right? Here's the center. Any point on the circle, let's just call it there. If I draw that segment, that would be a radius. So let's find the distance between these 2 points. So the distance equals the square root. This will be my x1, y1, my x2, y2. So we got a negative 1 minus 2 squared plus a 1 minus 3 squared. The distance equals the square root of negative 1 minus 2 is negative 3. Negative 3 squared is 9. 1 minus 3 is 2. 2 squared is 4. So the radius is the square root of 13. Let's build our equation. The center is 2 comma 3. That's our h and our k. So x minus 2 squared plus y minus 3 squared equals r squared. Square root of 13 squared is just 13. All right, let's move along. Standard equation of a circle with diameter AB, where A is 3 comma 0 and B is 7 comma 6. Okay, we're not going to go through this one a whole lot. Oh, we probably should, I guess. We need to find the midpoint. All right, if the diameter is 3, 0 and 7, 6, I'm not going to put this on an actual coordinate plane. Okay, if that's the diameter of some circle, then the point in the middle, that must be the center of our circle. Okay, so let's use our midpoint formula to find the center. So the center of the circle, 3 plus 7 over 2, 0 plus 6 over 2, 10 divided by 2 is 5, 6 divided by 2 is 3. The center must be at 5 comma 3. Okay, that's good. That'll be our h and our k. We also don't have the radius here. There's two different things that we could do here. Okay, you could find the length of the full diameter, okay, by taking the distance formula, and then we could divide that by 2 because we know the radius is half of the diameter. The other thing we could do is, now that we have the coordinates of the center, we could just use this point and either one of these two in our distance formula, and then we would actually be finding the radius, because the center to one of these endpoints would be the length of the radius. Doesn't really matter. If you want to find the radius first, obviously you'd find the diameter and then cut it in half. Okay, but let's use our new point that we found, the center, and let's just pick this 3 comma 0 point. It's easy sometimes to work with a 0. So the distance between the center and that point, here's my x1, y1, x2, y2. We have 3 minus 5 squared plus 0 minus 3 squared. The distance would be the square root. Looks like it's going to be the same as the last one. Negative 2 squared is 4. Negative 3 squared is 9. The distance is the square root of 13, which means the radius, because that's what we were finding the length of, is the square root of 13. Let's write our equation. X minus 5 squared plus y minus 3 squared, because that's our center, h and k, equals radius squared would be 13. All right. So it looks like we've run out of time on this video. So this will be part 1. Part 2, just be a short video working on examples 7 and 8 very quickly.